We are going to just dive into the world of algebra today. What I found over the years is that students are petrified of algebra. We've got so many students so scared. I remember a particular day way back when I started teaching GED classes. I was so excited to teach, and I stood in front of a class of students and I said, "Today we are going to start my favorite subject, algebra." And right then, a gentleman stood up, grabbed his possessions, and literally ran out of my classroom. A gentleman who, up until then, had been sitting in the front row and taking notes, doing just great, never came back again, despite my repeated attempts to call him, get him back in the classroom. Such fears we have related to algebra. In fact, students are always sending me these kinds of memes. And then Satan said, put the alphabet in math, or stop asking me to find your ex, Kate. He's never coming back. Or that whole, I used to be good at math. And then the alphabet happened. Why the heck do we put letters in math anyway? I mean, what's the point? That's the very first important thing you need to understand. And it turns out variables, letters, that's what we call them, variables, actually serve more than one purpose. Letters get used in a lot of different ways. First one, we can use a letter, also called a variable, to represent a single number. Here's a great example. So what am I saying here? I'm saying that there is a single number, x, that if you add 3 to it, you get 6. And I don't think you need to be an algebra ninja in order to tell me what x would have to be in this case. What number is that?
3.
Absolutely. So that's all I'm saying here. I'm saying, well, if I made x 3, this would be a true statement. So in this case, x is a single number. Here's another example of a statement like that. M, in this case, is a single number. There is a number m that if I subtract 4 from it, I'd get 2. So again, help me out, guys. What number would m have to be?
6.
Excellent. Now, this one might look a little scary to students who aren't used to the way that we do things in algebra, the way we designate things. But when two things are shoved up together like that 3 and that r, that means that they're multiplying. So what I'm saying here is that there is a number r that if I times it by 3, I get 6. So again, we don't have to have too many algebra skills to come up with what r would have to be. What number would r have to be?
Yeah.
Absolutely, 2. This is a case where a letter, a variable, represents a single number. And we're going to look at a lot of these a little later today. So you'll get practice with them. If you're going, how did they come up with those numbers? They didn't pop into my head the way they popped into Ariana's and Alicia's. That's okay. You don't need to have them pop into your head. I'm going to give you skills in order to do what we call solve. But for now, I want to keep talking about the other ways we use letters. We also use letters to represent not just one number, but a group of numbers. Great example of that is when you see these other signs, not the equal signs, like the less than signs or the greater than signs. So I'm going to read this statement. This is in the language of algebra here. It says x is less than 6. No, I'm not saying it's some number, a single number less than 6. I'm saying it's all the numbers less than 6. So somebody tell me a number less than 6.
4.
4 is in that group of numbers.
1.
Sure, 1 is less than 6. It's part of a group of numbers. And that's what I'm saying here in this statement. I'm saying x is a whole group of numbers, every single thing that's less than 6. I could see another example of that. This particular statement says m is greater than or equal to 15. That means, yes, m is 15, but 15 is part of a group, all the things bigger than 15 as well. So 16, 84, 100.79, 1.5 million. All of those things are part of this group that m represents. So a variable can represent a single number. A variable can represent a group of numbers. Here's my personal favorite. We can use a variable to represent all numbers. This one throws students sometimes because you're not used to talking in my language. So I just want to back up. You can just ignore what I have written on the screen right now. And I want to just talk about numbers that we understand. You guys, if I had the number 5 and I added 0, what would my answer be?
5.
Beautiful. How about if I took something uglier and bigger like 17 and then I added 0? What would I get?
Same answer, 17.
Brilliant. I think Alicia's noticing a pattern. What happens when we add 0?
A number plus a 0 is going to be the same answer.
You brilliant thing. That's exactly what I want to say, but I don't want to say it in English like you just did. I want to say it in algebra. All numbers, if you add 0 to them, you get the same number. And here I used a letter to represent all the numbers. It doesn't matter what A is. For all numbers A, this principle of 0 will remain true. And so here I used a letter to stand in for all numbers. Similarly, we could do the same thing with 1b equals b. Remember, when two things are shoved together, they're multiplying. So we know what happens when we times 1 by a number. If I times 1 times 5, I still have 5. If I times 1 by 83, well, I still have 83. So if I want to express this little lovely always true rule about 1, I can say that 1 times the number b, I shove them together to say they're multiplying, is always just the number b. And again, I'm using b to stand in for all the numbers. I can also use a variable to represent any number. For example, here, if I say r plus 17, this is not like the first problem where I can solve the mystery of what r is. I don't have enough information. This just says there's a number r and you should add 17 to it. How could I add 17 to a number that I don't know? And so this is like a rule. It's like somebody giving you directions. It basically says for r, whatever it is, I want you to add 17. So, Henry could say, Kate, I want r to be 3. And I'd say, okay, Henry. And I'd say 3 plus 17 is 20. I'd obey these directions. And Mason could tell me, well, I want r to be -4, Kate. And I would say, okay. And what would I do with it? I would add 17. It could be any number. I would do the same thing with it. Similarly, there's another one, same thing. Whatever f is, f could be anything. You could tell me any number for f and I would follow the same directions. I would take f and I would subtract 92 from it. So a lot of different ways we can use letters. Now, the very first and most important skill that we need in algebra is solving that mystery. I know you guys have heard that word solve before. It comes up so much in math. It is so important that you guys understand what it means to solve. All the students think that solve means find the answer, and solve does not mean find the answer. It's one way of finding an answer, but it's a very specific way. And if you don't know what it means to solve, you're going to get really mixed up when we get into the level of complexity that they have on the GED. So that is like our goal today, to figure out exactly what it means to solve. Now notice what I wrote here. I said, how can I solve the mystery of X? Because guys, when we're solving, X is not a mystery anymore. We are going to find out exactly what number X has to be. In order to understand solving, you have got to understand the difference between an expression and an equation. As it turns out, up until algebra, most of everything you've actually seen in math was an expression. I'm going to give you an example. 2 plus 4 is an expression. Now you're going, Kate, what is an expression? So let's pop down a definition here. An expression is any combination of 3 things happen in expressions, okay? You're going to see numbers. The next thing you can see in expressions are what we call operands. Those are those operation symbols like plus, minus, that tell us what to do. And I want you to understand what I'm talking about when I use this language, but the GED is not a vocab test, so you don't have to have all these words memorized. Any combination of numbers, operands, and or variables. Those letters are going to come up. 2 plus 4 is a pretty simple expression that we saw back in elementary school, but our expressions could get more complex than that because they could also involve letters. 3y plus 7 all divided by 11. This is an expression. It's some combination of letters, numbers, and symbols. And by now, if I were you, I'd be asking, well, Kate, isn't all math an expression then? I mean, we've always just been combining numbers, letters, and symbols. What makes it not an expression is if it has a relationship between expressions. Let me show you what I mean. Here's an example. Now we've graduated. We are no longer in the world of expressions. We are in the world of equations. Anybody just want to take a wild guess about why I would call this sucker an equation?
It has an equal sign.
Anastasia says, I see the equal sign. Brilliant. We have that equal sign. And not only that, because some students think as soon as they see the equal sign, it must be an equation. Sometimes in math, we use an equal sign, but it's not an equation. Go ahead and look over at the thing I just wrote on the left-hand side here under expressions. 3 times 14 plus 11 is an expression, not an equation, even though it has an equal sign. That's really weird. Why would I call that one an expression, but the other one an equation?
The equation has a non-number or variable, and the other one doesn't have any.
Oh, well, I could have easily done it with the letters, so let me not confuse you that way. Let me go ahead and slip a letter in there.
The equation has a result.
Ah, I love it. I love it. What are you talking about when you say the result?
The number 16.
The number 16. Okay. So it's not so much about it being a result or an answer, because it could have been way uglier than 16, but an equation has two sides. There's something on either side of the equal sign. It's not just a free floating equal sign. When you see that equal sign that's between things, that's giving you a relationship between two different things, that is when we have an equation. Make sure this gets in your notes. An equation is basically when you have one mathematical expression equivalent or equal to another mathematical expression. It has to have two sides. When can we solve? I mean, that's really the question we've got to answer, because this is what happens to newbie algebra students. They get their rules all mushed up. I don't know how many of you have had this experience that you work really hard. You learn a lot of rules. Then you go in to take the test and you have no idea when to do what. And you're just hoping and praying and guessing. Those students do crazy things in the land of algebra. So there's two big basic playgrounds we play on. We have always in math done what's called simplifying. Simplifying is actually when we obey the operands. A lot of teachers do not use this word when they should. It's one of my pet peeves. I really get when I train other teachers, I yell at them for this. But what does it mean to simplify? Simplify is when you do what the sign tells you to do. This expression here says 2 plus 5. The symbol there tells me to add. If you obey that symbol and you do what it tells you to do, you actually do the addition, you are not solving, you are simplifying. 2 plus 5 is 7. I just simplified the expression. Now, simplifying can get real complex. I mean, it happens in algebra too. And don't worry too much if you don't have any algebra experience and you don't know how to do this problem, but I'll just show you that we do also simplify in the world of algebra. Don't think that this is only something that we did back in the days before letters. You know, if somebody said to me, well, I have 2 x's and 5 x's, and I'm trained in algebra, I know how to add up x's, and I could just count up the x's. Oh, 2 x's over there, 5 x's over there. I know how to simplify this. I know how to perform the indicated operation, in this case, adding. And so I could do that. I could add and get 7x. So we simplify in algebra, but there is something else we can do in algebra that's new. We could never do it before. We were not able to do it in arithmetic. You haven't even been doing it up until the point you reach algebra. Solving, we have not been able to do until today. So solving is finding the value of the variable that makes the statement true. Now you might be saying, what statement? Let's go ahead and take a look at a case of something I could solve. So this is an equation. I have a relationship here. I'm telling you that the left-hand side, x plus 1, has got to be equal to the right-hand side, 9. There is a value of this variable that could make this statement true. It could satisfy this relationship. What number would x have to be in order to make this statement true? What number, if I add 1 to it, would give me 9?
8.
8. Now, we are going to speak in complete math sentences because math is a language and we need to learn the grammar. So what Ariana is telling me is that x is 8. Now you could write that out and you could spell out the word is, spell out 8, or you could use the symbols like I do because I'm a lazy mathematician. Ready? So here's what Ariana told me. She told me x is, it's equal to, it is 8. Beautiful. And I've solved this mystery. X isn't a mystery anymore. I know what he's equal to. That's not what I did on the left-hand side. If you look at this sucker on the left-hand side, I still do not know what x is equal to. That statement still says, whatever x is, multiply it by 7. And that was all the work I was able to do because I didn't know what X is. But see how the equal sign here is between these two numbers? Now it is solved. I do know what X is. X is 8. So solving is when you figure out what the letter is equal to. Simplifying is just when you obey the sign. And here's the important thing that you must take away, and you must understand for the GED. We simplify expressions, but we solve equations. If it's an expression, all you're ever going to be able to do is simplify it. You're never going to be able to solve the mystery. Oh, but if it's an equation, now we can solve. Now we have that lovely power. So, well, the question is, how do I, right? We've got some brilliant women in this group here. Ariana and Alicia and Anastasia have been just throwing numbers out there, just seeing what the answer should be. And I think that's brilliant. I think that's wonderful. But the problem is the equations on the GED are complex. 5, 6 steps, fractions, negative numbers, decimals. I mean, they'll give you a headache. So you've got to have more skills at your disposal than the answer just popped into my head. How do I solve an equation when I can't just see what X should be? We use inverses to isolate the variable. That is how you solve. And the nice thing is, this isn't only how you solve equations, it's also how you solve the other thing on the GED, inequalities. Let's talk about those two phrases, because if you don't understand them, you won't know what the heck I'm talking about. Does anybody know what the word inverse means?
Backwards.
Oh, I love it. Backwards. An inverse is a mathematical opposite. It's moving backwards. So when I talk about an inverse, I'm talking about the opposite operation. So you are not going to be able to do inverses unless you know your opposite operations. Let's start with the most basic operation. First thing you learned was addition, right? We started putting those groups of numbers together. But shortly after you learned addition, you learned how to undo addition. You learned the opposite or inverse of addition instead of putting groups together to reach in and take a group out. Anybody know what the opposite of addition is?
Subtraction.
Subtraction. Now, after we learned our addition and subtraction, we started doing multiplication, where we did a bunch of equal-sized groups put together in the same place. And that was great. But then everybody hated it as soon as we flipped into the opposite of multiplication. We started breaking things apart back into those same size groups. Anybody, what is the opposite operation of multiplication?
Division.
Division. Now, if all you know is addition, subtraction, multiplication, division, those are your only operations that you know, you're kind of going to be at a beginner level today, and that's okay. But we're at all different levels across the board when we study for our GED. Okay, so addition, subtraction, multiplication, and division are not the only operations that come up on the GED. We also have exponents. And there's 2 of them that frequently come up in equations that I want you to be aware of. So the first exponent that we need to look at is the second power. That's when you have that little floating 2. So we need to understand the opposite of the second power. Now, you guys have heard the second power being called square. Anybody know what the opposite of square is?
Is it square root?
Brilliant. And you know, no mathematician worth their salt is going to spell out the word square root. We're going to use the symbol. Looks like that old divide into symbol we used way back in the day, but it's got a little check on it. That symbol, by the way, is known as a radical, but you don't have to know that for the GED, but isn't that radical? Math teacher humor. So that one comes up. That's more of an experience level. And if you're super advanced, I want to show you one more. There's also an opposite of the third power, aka cube. Just like the opposite of the second power, the square, is the square root, the opposite of the third power, aka the cube, is the third root or cube root. Looks exactly the same way, but there's a little 3 tucked in your symbol. So don't you freak out if you see that little 3. That just means I want the opposite of cubing instead of the opposite of squaring. The opposite of cube is cube root. Again, if you're a newbie, you can walk away today with just add, subtract, multiply, divide is fine. But if you've been around for a while, let's up our game to a high school level with looking at some opposites of some more complex operations. So we said we were going to use inverses, but we're going to use inverses for a purpose. We are going to use inverses to isolate the variable. What in the world? There goes Kate with the math language again. Well, we've been talking about what a variable is. We already know it's the letter. So I want to do something with the letter, but what do I want to do with the letter? If I say isolate, what does it mean?
Does it put it alone by itself?
Absolutely, right? If you go to jail, don't go to jail, ladies, but get your GED instead, get educated, and then send me Christmas presents. But if you go to jail and they put you in isolation, that means you're going to be all by yourself for a while. To isolate means to get something alone. Now, getting the letter alone where? Do I just write an X somewhere in the corner of my page? Is that what I'm talking about? No, I'm talking about in relationship to that equal sign. So when I say get the letter alone, I'm talking about on one side of the equal sign. How are we going to solve equations? We are going to use opposites, inverses to get the letter all by itself. Let's practice. So super duper important thing I need you to write down. I probably should have written it down. I probably should have made it its own slide. In fact, I probably should have hired one of those skywriters to write it across the sky. That's how important it is. Welcome to having power you've never had before. Make sure this makes it into your notes, but I've got great news. You can literally do whatever you want. We've never had this power before. All we've ever been able to do is be obedient, but we can literally do whatever we want to an equation as long as we keep the two sides equal. In fact, mathematicians are so anal about the equal sign. I mean, so anal. I will just scold the crap out of my poor students if they just throw around equal signs like they don't matter. The equal sign is sacred, but as long as you keep the left and right equal, you're good to go. Take a look at this equation. We can see it's an equation. I've got something going on here on the left-hand side. I've got something going on the right-hand side. Those are expressions, and those two expressions have an equal sign in between them. This is an equation. My goal here is to solve. I said we were going to solve by isolating the variable, getting it all alone using opposites. Let me show you what I mean. Here's the deal, guys. I couldn't obey this plus sign if I wanted to. I cannot do x plus 43. How could I do that? X is a mystery. I don't know what he is. I couldn't do that math if I wanted to. And so what I'm going to do instead is I'm going to do the opposite. I'm going to use that inverse to get rid of this math. Since I can't do the plus 43, I'm going to get rid of the plus 43. And I'm going to pick out a different color. And if you are a newbie to algebra or you have ever really struggled with this, you should use a different color for this line as well to help you start seeing what I'm doing here. So I am going to do the opposite of adding 43, and that is subtracting the 43. You guys can imagine you're walking around with no money and I give you $43. Okay, that's nice. I just added $43 into your life. But then I say, give it back. I take it away. Well, guess where you're at? You're right back where you started. You have nothing again. So what happens when you add 43 and you subtract 43 is they go away. We just got rid of the math. But here's the deal, guys. You cannot just go jacking around with math, doing whatever you want like that. Equal sign doesn't matter. Kate will have a hissy fit. She gets all red like this. It's not good. We've got to keep the two sides equal. If you subtract 43 from the left-hand side of the equal sign, you have got to jump across to the right-hand side and subtract 43 over there as well. If you're a newbie student or you've always struggled, label that blue line as your balanced change line. Notice how the only thing on there is the exact same operation and the exact same number. Now I want to see what my new equation will be after making that change on the left and right-hand side. Pick back up that original color you were using. I was using black, and every time I write the new equation, I'll use black. So let's see what happens. Well, adding 43 and subtracting 43 cancel. So that 43 is gone. But don't miss the fact that there was an X on the left-hand side, and I haven't done anything with that X yet. It drops down. You keep the equal sign right where the equal sign was, and there's the math to do. I don't have to guess what to do. I don't have to memorize. The opposites told me exactly what to do. And more great news, anytime you do algebra on the GED, you get a calculator. So I don't even need to see your scratch work. Literally, I don't care where you get this number. You could use your calculator, you could do the scratch work, you could call your mama and ask her what 145 minus 43 is, whatever. I get 102. Now let's talk about how we know we're done. Today, we're only going to do one-step equations. So you're going to be like, I did one step, I'm done. But on the GED, you do 5, 6-step equations. How are you supposed to know when you're done? Well, you're done when the letter is isolated. It's all by itself. See how X is alone? This sucker is solved. And why do I consider it solved now? Well, I just solved the mystery. I know what X would have to be to make that original statement true. Remember, we can read that equal sign like is. X is 102. That is the single specific number X would have to be in order for me to take X, add 43, and get 145. It's only if X is 102 that that statement will be true. But one of the things that students often struggle with when they're solving is when the letter shows up on the right-hand side. They just lose their snot and freak out. So if that's you, I want you to do me a favor. I want you to draw a little line through the equal sign. The equal sign there is what tells us the difference between the left-hand side and the right-hand side. And remember your goal. When you're solving, you want that letter alone. That is your end goal. Now, right now, the letter is not alone. P is not alone because there is a number over there on the same side as P. You guys, what number is with P?
Minus 142.
Exactly. The 142 is the one with P. That's the one that's got to go if P's going to be alone. Don't be confused about which number needs to go. It's whoever is hanging out with that letter. So I need to move 142. Now, as Anastasia just pointed out, that 142 is currently subtracting. We said that we isolate, we solve by using inverses. So I'm going to need to do the opposite of subtraction. What is the opposite of subtraction?
Addition.
Addition. Lovely. I am going to add 142 if I want to get rid of a subtracting 142. But here's the deal. You break math if you make my two sides unequal. You're not doing something true anymore. You're off in left field. You're so confused. I need my two sides to be equal. So if I went and added 142 to one side, guess what I got to do? I got to jump across the equal sign and add 142 over there as well. I have got to keep my balance. Let's see what happens after I make that change. Now, something really neat is going to happen on the right-hand side. As we know, if I take $142 from your account, but then I put $142 back in, nothing's happened. It cancels out. No big deal. And so what I see on this right-hand side is the subtracting 142 and adding 142 cancel. So all I have left over there is P. Equal sign is always going to stay nice and steady on that line. Students who long time struggle with algebra drop equal signs like they don't matter. You guys, they matter. Don't lose your equal sign. Every new equation should have an equal sign. And now there's the math to do. And you might say, oh my God, Kate, I forgot how to do decimals. You get your calculator. And 147.9 is what we get. Now the question is this solved? I got a lot of students freaking out. Kate, this is not solved because I don't like that the P's on the right-hand side. Guys, the only requirement for it to be solved is for the letter to be alone. That letter is alone. This sucker is solved. Now, can you write it the other way? If you want to, it doesn't matter. But saying 147.9 is P is the same as saying P is 147.9. So I don't care which way you write it. This sucker is solved. The letters alone. Now, still a beginner level, but we are kicking it up a notch because there's something happening here with the symbols that's not like the other ones. On the last two problems, it was obvious what the equation said, but this for a lot of students is not obvious. They look at that 11R and they don't know what's happening there. So take note if you're new to algebra and don't know this. And if you're old to algebra and do know this, you could just start looking out the window at butterflies right now. But when a number and a letter are shoved together with no symbol between them, they are multiplying. Mathematicians are so lazy. We just don't even, we're like 11 times R, that's just 11 R's. And so we don't write 11 times R with a time symbol, we just write 11 R's. It's weird for students to get used to, but that's what this equation says right now. It says 55 is equal to 11 times R. If I am trying to solve the mystery of what R is, I am going to isolate R, get him alone, by using inverses, opposites. What's the opposite of multiply?
Division.
Division. Beautiful. I Again, oh, you feel so scolded by Kate. You're like, I just met you and you're yelling at me. Please, 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 please do not use this divide symbol like this. Do not write divide 11 with that little elementary school symbol, because as it turns out, the divide sign is not as powerful as it needs to be for algebra. We use a different symbol once we hit the world of algebra for divide. We use a fraction bar, and there's a real reason for that. It's because a fraction bar not only tells us to divide, it tells us exactly what numbers we're dividing with, which is going to become really important in multi-step equations. We can use that fraction bar not only to divide, but to group. And so super important that you get in the habit right now when it doesn't matter, so that when it does matter, you won't be screwed over. That says divide by 11. It doesn't say, oh my God, there's a fraction, I should cry. It says divide by 11. Now, I can do whatever I want, literally, as long as I keep my balance. So I'm going to come over here and, like a mathematician, not a third grader, I'm going to use that for my divide sign, and I'm going to divide by 11 again. Notice, once again, my change is balanced. I can do whatever I want as long as I do it to both sides. Same operation, same number. Now let's see what our new equation will be. On this right-hand side this time, multiplying by 11 and dividing by 11 are opposites. They cancel. And so what am I left with? Well, just a single solitary R, just that one R. And then on the left-hand side, there's the math to do. 55 divided by 11 is 5. And now it's solved. R is alone. Okay, I need you guys to be strong, because I'm about to show you something that makes GED students start puking and running and crying. And if the algebra didn't get to you, this next thing does. So be strong. You can do it, guys. You ready? Here we go. Oh my gosh, it's a fraction. Okay. It's like the other F word, right? I can make grown men cry with the F word. The day you got the equal sign, you got the power to get rid of fractions. Haven't you always wished you could get rid of fractions? Because yes, this is a fraction, m over 4, but it's also an act of division. Remember, we said that fraction bar means the same as division. So one way to read this is m divided by 4 is equal to 19. We could get rid of that fraction right now by getting rid of that act of division. Again, when we solve, when we work to get a letter alone, we use opposites. So guys, what's the opposite of division?
Multiply.
Now write this down, because you need to get used to it if you're a new algebra student. Watch how I multiply. Once again, I do not write times 4 underneath. And it's really important that you do not either. I need a more powerful multiplication symbol that not only multiplies, but can be used to group. So same thing like before, I'm not going to use a times sign. I'm going to use our favorite way to multiply in algebra, which is parentheses. You take the entire left-hand side, you enclose it in parentheses, and you put the 4 up top. So it's really clear that it's multiplying. And that is how I am going to multiply that entire side by 4. And I want you to write it just like that and see how I did it in a different color so you can see the change. And that was so you can remember to keep your change balanced, because whatever we do to the left-hand side, we need to do to the right-hand side. So enclose the entire right-hand side in parentheses, and we're going to multiply that by 4 as well. Now, a lot of students are still crying, looking at this going, oh my dear God, Kate, I don't know what to do. It's so gross. It's so ugly. Don't forget what you were trying to do. Multiplying and dividing by 4 opposites, they cancel. You were trying to get m alone. And guess what? You used opposites, so you did. M is now isolated. It's all by itself. That 4 is gone. And there's the math to do, nothing to do with fractions. Hallelujah. And you can do that in your calculator. 19 times 4 is 76. And this is isolated. I got rid of my little fraction problem. M is alone. I put this in the experience level because it takes a little bit of knowledge about negative numbers in order to solve this problem. You know, it's really hard to know what the opposite is if you don't even know what's happening. So is there anybody here that's brave enough to read this equation just the way it is? What does it even say?
24 equal to -3 times j.
Beautiful. I love what you just said. Times j. I got a whole lot of students who make a really big error here. They say, I'm going to add 3. They just see that little minus sign, they want to add 3 so bad. And I get it. I understand why. But did you hear what Anastasia said? She said -3 times J. We're supposed to use opposite operations. What's the opposite of timesing, you guys?
Divide.
Divide.
Hi.
It's not time to add. It is time to divide. I am going to divide that entire side. Now make sure, and I'm going to put this in our notes because so many students still change the sign. You already did the opposite. The opposite was the divide. Make sure you divide by exactly the number you want to get rid of. You want to get rid of a -3, divide the entire -3 away. Don't leave negative signs hanging out.
This is what I was getting wrong at first because I used to divide it by plus.
Yes, and that's
Yeah,
doing
I
opposites
changed the
twice.
sign.
There's no reason to do opposites twice. We already got the opposite of multiply, it's divide. So I can do whatever I want as long as I do it to both sides. Now there's another place students go wrong. All of a sudden it'll become +3 on that side. You just broke my equal sign again. Oh, it's my big pet peeve. Respect that equal sign. Do exactly the same thing on both sides if you want them to be equal. Now let's see what happens. Multiplying by -3 and dividing by -3 are opposites, so they will cancel just like I wanted. Hallelujah. J will be alone on its side of the equal sign. And there's the math to do. So I'm going to do this in my calculator. 24, and you can use the divided by button, that's fine. But make sure when you hit the negative, you use that little, not your minus button, but the little negative key down at the bottom by enter. And I press divided by -3 and it tells me that it is -8. So what number would J have to be to make our original equation true? J would have to be -8. This is one of the most common student errors made. That's the reason why I included here in the experience level practice. Now we've gotten used to opposites. We've got to graduate to fine tune our skills so we're not getting caught up in things like this. Here's another one from the experience level of practice. Now, I do have to warn you about something. When you go a little further in math, you will find out that this problem actually has more than one answer. You'll be like, Kate, you lied to me. You only showed me how to find one of the answers. And it's because I know how this comes up on the GED. It only ever comes up one way on the GED with one of the kinds of answers. So if you're in advanced math, you don't have to go like into the YouTube comments and comment on me that I'm an idiot and don't know both ways. I do. So that being said, let's go ahead and look at this. A lot of students throw up their hands on a problem like this and say, Kate, there's nothing to do. R is alone. But I say, you're a big fat liar. R is not all by itself. No, it's not really a number hanging out this time. It's an operation. I still need to get rid of it. I need to get rid of the square. If R is going to be alone, I need to do the opposite. Now we wrote that down way back when we were doing inverses. Does anybody remember what the inverse or the opposite of square is?
Square root.
Square root. Bingo. So I am just going to sit here and I'm going to draw a square root symbol right over that entire left-hand side of the equation. And you say, Kate, can I do that? And I say, you can do whatever you want, like literally, as long as you do it to both sides. So keep your balance. Let me see a square root symbol over there as well. Let's see what happens. Well, square and square root are opposites. You don't have to figure out what's going to happen. They're going to cancel. And so what am I going to be left with on the left-hand side? Hallelujah, R's alone. Equal sign stays nice and steady, and there's the work to do. Now, I do recommend that you have your perfect squares memorized up to this one so that you already know what the square root of 144 is. But even if you don't, guess what? Once again, you can do it in your calculator. This one's a little more tricky to do in your calculator though. So if you are not used to using a TI, here's how you do it. First, you have to hit the green button up at the top left. It's labeled second. And then you can hit the X squared key. Looks like this. And the whole reason why I want it is because up above the X squared key, that's where you're going to see the square root symbol. Anytime you want one of those green symbols that are up above the keys, you have to press second. So we'll press second, then X squared, then we'll type 144 and hit enter. I skip almost all of basic math when I teach my students how to pass the GED, and I have a real reason for that. It's because I haven't met a student yet who wants to spend 10 years with me. I'm not going to teach you 12 years of math, 10 years of math. I mean, I'm funny, but I ain't that funny. You don't want to spend the next 10 years of your life doing the GED. So we have got to focus on the math that the test is really about, algebra. Algebra, algebra, algebra. So you can do any of your basic math on the calculator. You can totally pass and know no basic math, including your times tables. That being said, I love times tables, okay? Don't get me wrong. But I just realized that we are on a time crunch. Put that into your calculator and you will find out that the square root of 144 is 12. So R is isolated, it's all by itself. That is my answer. And this again comes up a ton in the geometry problems that happen on the GED. You will need this exact skill we just used. So here's another practice that I put in the experience level because a lot of students aren't sure what to do because it looks really confusing. I have two symbols going on. There's a -5, but then there's a plus n. Should I add? Should I subtract? How do I even find the opposite here? I'm going to do first what most students do, and then let's talk about why that's a wrong answer. So let me grab up red so you can know. Most students see this plus sign between the two numbers and they go, okay, I've got to subtract 5. And they do something that looks like this. And it's due to you not understanding something about positive and negative numbers. And that is that plus sign is not telling you what the 5's doing. The plus sign is telling you what the n's doing. The n is a number that's going up. It is a number we're receiving. But the 5 had a minus sign in front of it. That means we're going down 5. So yeah, we started by going down 5 and then we went up n, but the 5 still went down. So unlike the last one where the two were shoved together, they're not shoved together, they're not multiplying, they're separated by this plus sign. This is a line of numbers adding and subtracting. Okay, so I'm going to have to move it through addition, subtraction. However, that 5 is a number going down. It is a number subtracting. And so how I'm going to get rid of it is I'm going to add it. Why did I choose to do that? Well, think about that. If you have -$5 in your bank account, woo, when I was a single mom, I'd go negative all the time. It was so hard. So -5 in your bank account, and then you put $5 in, what's going to be the result? Well, you'll have a zero balance. You went -5, but then you put the $5 back in, it just zeroed out. This cancels out. Now you say, Kate, but what about that plus n? Well, what am I adding plus n to? I'm adding it to 0. And way back at the beginning of this lesson, you guys told me if I add with 0, nothing happens. So if I add n with 0, all I have left is n. So that's all well and good to have n alone, but remember, you can't just go around making changes because you feel like it. If I add 5 to that left-hand side, I have got to add 5 to that right-hand side as well and keep my balance. And so there is my math to do. 106 plus 5 is going to give me 111. Now notice I didn't put this as advanced. I put this as experienced. And yet I know that I got a bunch of students out there just puking at the sight of these fractions, just so scared. Once again, you don't have to understand about fractions. What you have to understand about is algebra. This is the exact same skill we've been doing, and your calculator can handle the nasty. All you have to handle is the opposites. So let's look at t. T is not alone. There's a number hanging out. There's the number. We've got to get rid of it. If I want to get rid of it, I have to do the opposite. So what is that nasty, ugly 2 3/7 doing with t? This whole number and the t are separated by a minus sign. So it's subtracting. So if I want to get rid of it, I have to do the opposite of subtracting. What is the opposite of subtracting, guys?
Addition.
Addition. And we're going to add exactly the number we want to get rid of. We want to get rid of 2 3/7. We'll add 2 3/7. That if I do it to the right hand side, I also got to do it to the left hand side. Exactly. Let me see your add, same operation and same number on both sides. Now you say, but now Kate, it's come down to the wire because now I actually have to do math because yeah, it'll cancel out on that right hand side so that t's alone, but on the left hand side I'm screwed. And I say, no, you're not. You just need your calculator. You can totally type in mixed numbers in your calculator using the UN/D function. That's how you type in mixed numbers. Now what you're going to notice is that UN/D function is in green. So that means if you want to use it, guess what? You need that second button. So we'll hit the green second button. That UN/D button is right over N/D. And then it's really important that you see this on your screen. It should be like blinking these boxes and looking like this. If it doesn't look like this, you're in the wrong mode. You need to switch your calculator to math print mode. And I have plenty of videos up on that on the crash course on YouTube. You can go check them out. But you need to be in math print mode for fractions to work well. So second UN/D, we get our boxes and then we can just arrow around to type 1 1/3 plus 2. We're going to have to get the UN/D key again to type in 2 3/7. And again, I'm just arrowing around to type into my little boxes and I arrow out to press plus. second again, and then n over d to type 2 and 3/7. And I got a weird number, 79 over 21, and it's not wrong. It's just not in the form I was expecting. These are both mixed numbers, so I'm going to really quick do a conversion. You don't have to know how to do this by hand. Again, you can do it in your TI. I want it to look like these other numbers look, with a whole number and a fraction portion. To do that, you actually need to hit second again, because you need this little convert. It has this symbol to turn that regular fraction n over d into a mixed number, un over d, and it's right over the times 10 to the n, and I see that's the same as 3 and 16ths 21s. So why is this in the experience level practice? Well, you need some calculator skills for it, but you don't need fraction skills, which would put it in the advanced level practice if I were trying to add and subtract fractions by hand. Well, let's start the advanced level practice. So a lot of students would just throw up their hands in despair. I can't do this. Now, good news, I've never actually seen one with this operation on the GED. In the algebra section, but it does show up and in another way. So this is important to understand, and you'll need it for your college classes as well. And that's why it's in the advanced level practice. So P is not alone, right? We can see that there's this little floating 3, this third power hanging out with P. I want to get P alone. I'm going to need to get rid of that little third power. Does anybody remember what the opposite of the third power, or cubing, is?
Cube root.
Absolutely, cube root. And you say, I don't know how to do cube root. Again, once it's okay. It's okay, you don't know how to do it. Your calculator will do it. You just need to know that it's time to do it. So watch what I'm going to write here. I'm not just going to write the square root symbol. I'm going to come in the little check mark and tuck that 3 in there. That is the cube root symbol. Now I can literally do whatever I want as long as I do it to both sides. So I'm going to come over here and I'm going to do the same thing. I'm going to cube root the right-hand side. So let's see what happens. On the left-hand side, cube and cube root are opposites. They cancel. P is alone, just like I wanted. And on the right-hand side, this one's a little trickier to type into the calculator. First, you need to type in the index, the little number in the check mark. So you will type the 3. And then we still do need a green function. So you will need to hit that green second button. Okay, but you need to go actually right above the one you used last time and use the caret button. It's a little key that has like this little arrow thing on it, known as the caret. Right above that, you're going to see this like X root. You use this anytime you're doing anything that's not a square root. So it could be a cube root, a fourth root. The only one on the GED is a cube root, okay? But you go on your college math, fourth root, fifth root, eighth root, 12th root. You can type the 3, the second key, and then this key. And then you'll be able to type in 64 and enter. And if you do that correctly, you will get 4. Again, if you need additional calculator practice, that's what's tripping you up, hit up the calculator videos. But that is how we get the cube root of 64. And now P is alone. This sucker is solved. Once again, I need you guys to breathe. Just breathe. Don't panic. What I've found is that students just shut down at the sight of a fraction. They're so concerned with the fact that they struggle with fractions that they forget all the algebra they know and that they're strong at. Okay, so once again, I do not want to focus on the fraction here. What I want to focus on is the alg skill. We'll let the calculator handle our fraction, just being able to identify opposites. All right, now as it turns out, there's actually at least 3 ways to do this problem. So this is not the only way. So if you know some other way, you're great. But today we're really focusing, honing in on the skill of opposites. That's the way I'm going to use. What's happening with the 3 over 5, the 3/5, and the q?
It is multiplying.
It is multiplying, right? Now, Alicia's like, but you said divide. Yeah, one way to think of that number, the 3 and the 5, is 3 divided by 5. But what's that whole fraction doing with the q? The whole thing. Well, the whole thing is shoved up against the q. So the whole thing is multiplying with the q. We're just going to use opposites. You guys, what is the opposite of multiply?
Division.
Exactly. I am going to divide, and I am going to divide by exactly the number I want to get rid of. The number here I want to get rid of is 3/5. There I go. If I divide one side by 3/5, I have got to divide the other side by 3/5. The shortcut that everybody preaches about here comes from people knowing how to divide fractions by hand. I mean, that's really what it comes from. But even if you don't know how to divide fractions by hand, you can do this math in your calculator. And here's how I'm going to do it. I'm going to type in 30. And then I'm actually going to use the regular divide by button here so that I don't get confused by the fractions, divided by. And then I want to type in the fraction 3/5. In order to type in a fraction, I need the fraction button. I'm going to use the n/d button so that I can arrow around and type 3 on the top, 5 on the bottom, and then I'll press enter. I get 50. All done in my calculator. All I had to know was how to enter in a fraction. And on this side, multiplying by 3/5 and dividing by 3/5, as ugly as it might be, it cancels, it goes away. You don't have to worry about it. And Q is alone. And I didn't have to know anything about fractions. All I had to know about was opposites. As if it wasn't mean enough to do fractions, sometimes they try to combine fractions with negatives and then all the students lose their mind. Is there anybody brave enough to read this one to me?
Over 2 equals to minus 4/3 times k.
Beautiful. I love how you said times. Yeah. 1/2 is equal to negative 4/3 times k. So what is this ugly number doing with k? Multiplying. So again, I don't have to handle ugly number. I just have to handle opposites. So you guys, what's the opposite of multiplying?
Division.
Beautiful. I'll divide by exactly the number I want to get rid of. I want to get rid of negative 4/3. I will divide by negative 4/3. I can do whatever I want as long as I do it to both sides. So I'm going to come across here and I'm going to say divided by negative 4/3. In order to get this first fraction, 1/2, you're going to need the n/d button. So I'll hit n/d. I'll use my arrow key up at the top right to get a 1 here and a 2 there. And then super important that you arrow out of the fraction before you hit divided by. You'll know if you didn't because you'll be like, my divide is inside my fraction. And then we can type negative, and that's with that little key down on the bottom. Hit n/d again so you can put 4 up here and 3 down there. So on the left-hand side, I got negative 3/8. And on the right-hand side, negative 4/3 multiplying and negative 4/3 dividing cancel. So k is all by itself. Now, the next kind of problem I didn't used to teach, but what happened was I was doing a practice test and I came across one like this. And a lot of my students panic when they see more than one letter. And this could happen on the math or the science. This skill is actually very commonly used in science class. Let's go ahead and look at this and realize that it's just an extension of exactly what we've been doing. It's nothing new. It says solve for J, and that's important. So let's make sure that we note what it means to solve for J. When I tell you to solve for J, I'm telling you that I want J alone. Let me show you what I mean. This says right now, we can see that J is not alone. And if you have trouble seeing that, once again, like I said, you can go ahead and you can write that little line right through your equal sign. And you can see that J is not alone right now. A is hanging out. Now you say, but I don't know what number A is. And I'm like, that's okay. Again, you don't have to know how to do the math. You just have to know opposites. So what is A doing with J? Yeah,
Addition.
according to this symbol, it's adding. So you don't have to know anything about A. You have to know opposites. What's the opposite of addition?
Subtraction.
Yes, the opposite of addition is subtraction. And what am I trying to get rid of? I'm trying to get rid of an A. And we also know, we've been doing it over and over again, that whatever we do on the left-hand side, we have to do on the right-hand side. So we're going to subtract A over there as well. We're going to keep our balance. We're going to keep the left and right-hand side equal. This is where the panic starts. This is where students start going, oh my God, I don't know what to do. These letters are so scary. But it actually, as it turns out, this is easier. Let me show you what I mean. Let's look at the left-hand side. Adding A and subtracting A are opposites. They cancel. My J is alone, just like I wanted. And now I got students over here once again, if they ever came out of the closet after the fraction problem, they're looking at this like it's impossible. You're right, it is impossible. I can't do R minus A because I don't know what R is and I don't know what A is. So you know what I write? I just say, oh, whatever J is, he's equal to R minus A. When you can't do it, you just write it down. What is R minus A? I don't know, it's R minus A. And you're done. And how do I know that I'm done? J is alone. This is solved. So let's look at one more example like that, and then I'm done. I swear this is my last problem. Really, really, I mean it. Solve for T. What letter do I want alone here?
T.
Exactly. So my goal is to keep T nice and steady. He's not going anywhere, but I need him alone. So R has got to go. Now your only job, guys, is to know opposites. So what are R and T doing right now, all shoved together like that?
Multiplying.
We've got to do the Opposite. What is the opposite of multiplying?
Division.
Division.
It doesn't matter how ugly your number is, what you need to know is the opposites. So I'm going to divide. And what am I going to divide by? Well, the thing I want to get rid of. I want to get rid of an R. You say, but I don't know what number it is. That's okay. Whatever number it is, we divide them away. You can do whatever you want as long as you do it to both sides. You just got to keep your balance. So I'm going to swing across the equal sign and I will divide by the exact same thing. Divide by R. Okay, let's see what happens. Once again, I actually argue that these are easier than when there's with numbers. Look at what I mean. Multiplying by R and dividing by R are opposites. They cancel. T's alone, just like I wanted. And what's it equal to? Well, it's equal to D divided by R. You say, what's D divided by R? I say, I don't know. I don't know what D is. I don't know what R is. There's no way to figure it out. You just write it down. D divided by R. This basically tells you if you'd like to find T, take D and divide by R, whatever they are. It's like those problems we did at the beginning where we said, well, it could represent any number. Very weird, but same skill of using opposite. And this is done, T's alone.
Basically, it go down, right?
Yes. I'm not memorizing with algebra. I'm looking. I tell my students a lot of times when you get lost in algebra, just look up. I just look at the line above to see what's happening. So right here, I saw that I canceled out my R and my R, and the only thing left there after the R's disappeared was the T. So that's what dropped. And then on this side, there's the math that I should do, but I can't. So I don't know what D divided by R is. So I just write it down. If you can't make it any simpler, you just write it down. Feel free to email me your questions at Light and Salt Learning, or you can drop it in YouTube comments when you're watching a YouTube video, and you might be my next video. That being said, you should spend at least half, maybe more, depending on just how you learn, practicing. So I've got a lot of students who binge watch videos or sit in classes, but then don't practice. And then they get really discouraged because they're working and watching all these videos, maybe even taking notes and never really seeing their scores increase. And that's because learning is different from remembering. You could learn and still not remember because learning is laying down new neural tissue. Your brain literally makes new connections. But guess what? If you never practice, your brain is a great recycler. It just picks up those new cells, says, I guess we didn't need them, and throws them away, uses them for another purpose. So you have got to practice if you want to remember. By practicing repeatedly, it tells your brain, this is important. Let's keep this. Let's build a strong neural connection, and it won't get thrown away.